All right, so for this video, we have systems of equations, but we're going to prefer or focus on the substitution method and see how that goes. So we have a few problems here. Substitution method is the following, okay? So you might have learned about graphing is one method, elimination will be another method. We talk about substitution, and there will be definitely times when substitution is preferred. And to better understand when it's preferred, you need to understand kind of what you're doing here. So here's what substitution says, okay? You have two equations. Look at the second equation here. Y equals -5. Specifically, what is y equal? If I asked you, what is y equal? You would answer y equals -5. So in this problem, what we are saying is, anytime you see a y, we can call it -5. We can say it equals -5. That's what y equals, -5. For this problem, we are told that every time you see a y, it's essentially the same thing as -5, okay? And that's what substitution is going to do. You're going to take a variable and you're going to say it equals something. And then anywhere else where you see that same variable, like in the other equation, you are going to substitute. Instead of the y that's in that first equation, you are going to substitute in place of y what y equals, okay? Just like any kind of situation you can think of, a substitute in a recipe, in a game, and as a teacher. Instead of the one that's there now, you're going to replace it with the other one that's basically the same, okay? Now, you can question whether or not a substitute teacher or a substitute in a game are of the same ability, but in this case, let's assume, because we're saying they are equal, we're basically taking the y that was there and replacing it with what it equals, okay? And the reason we're going to do that is the following. We cannot solve equations when there's two variables in the equation. However, if I was to rewrite in blue this equation down below, I'm going to have, okay, I have 2x, cool, plus 3 times, now instead of y, in parentheses, always put it in parentheses, instead of y, what did I know, or what was I told that y equals? Y is the same as -5. So instead of the y, I'm replacing it with the -5 that it equals, okay? Does everyone see that? Cool. Equals 5. I didn't change anything other than the y. The y got changed to -5, okay? Now, if you notice, my equation just has one variable, x, so I just solve it like I normally would. 2x, this is -15 when you multiply, equals 5. Adding 15 over, you get 2x equals 20. Divide by 2, you get x equals 10. Okay, so you found what x has to equal. Now, remember that when we're solving systems of equations, you're finding the solution, you're finding the intersection, if you think graphically, you're finding the coordinate, the x and y combination that works for this equation, or this set of equations. Just getting an x equals is not good enough. You also need the y, right? You need a coordinate. You need 10 comma what? Now this problem is unique because you already know what y has to equal. What does y have to equal? One of the equations says that y has to equal -5. Now, as you see here in a second, when we do another example, you won't always be told right away what y or x equals, so you're going to have to plug in and solve, okay? So we'll see how that is in a second, but in this case, you don't have to plug in anything. You know that y has to equal 5, okay? If you wanted to, you could have taken the x equals 10 and plugged it back into the first equation for the x. Just color code here just so you can see. You could have replaced that x with a 10 and solve that equation for y, and then you would get what y equals, okay? So that's what generally we're going to do. We're going to get one thing substituted in. You're going to solve that new equation that you rewrite, and you're going to get one variable, and you're going to take that variable and plug it back in. You'll see how that works in a second. Okay, so this next one. So when do you start using substitution? So that'll be a question we talk about later in the notes, but I'm covering it now. The times you want to use substitution is when you already have one of the equations already pre-made so that one of the variables is by itself. It doesn't always have to be y equals. A lot of times it will be, but it doesn't have to be. Could have said x equals, okay? If you have one equation that already has the variable by itself, this equation has y by itself, and we were told that y equals -4x plus 8. So that's a preferable time when you want to use substitution. So what do? Instead of the y, we are going to replace the y with what y equals, okay? We're told that y equals something. Okay, so instead of the y, we put in that something. So instead of y, I'm going to put it in parentheses. I'm plugging in negative 4x plus 8. That was the y before, right? Does everyone see color-coded there, right? It used to be y, now it says this, because that's what y equals. You still have a minus 2x. You still have an equals negative 10. Now you might say, Mr. Wog, why did you put that in parentheses? There's nothing else there. You're correct. You didn't have to put that in parentheses, but 99% of the time, there will be something in front. There will be like a 3 or a negative 3. So you want to make sure you remember to distribute if you're multiplying. So I'm just going to get in the habit of always putting in parentheses. Technically now, you don't really need the parentheses. There's no multiplication or anything going on there. Sure, you can get rid of them if you want. Okay. Combining like terms, you get negative 6x plus 8. This should be relatively simple solving at this point. If you're struggling with this part of this, that's something else we need to work on that is not new. This is other types of solving that in math, of course, it always builds on itself. That's why it's crucial, important to stay up to date with what you do, okay? So by substituting in, we replace the y with what it equals. We finished solving that equation. Nothing else changed in that problem because there was no other y's. We solve for x. Okay, cool. Now, different than the last problem, we don't automatically know what y equals, right? We didn't. Last problem, we were told y equals negative 5. This time, we don't know what y equals. It doesn't always end up being the same number. So here's the trick. You might have noticed in the first two problems, I put a box around the thing that like the y equaled. Here's why I do that. One is for visual effect, obviously. The second is to remind myself, okay, if I just take this x value and I plug it into the box, I would then figure out what y is, right? Isn't y just equal to whatever negative 4 times x is plus 8? That's what y equals. So y is really just equal to whatever negative 4 times our x, but we just found x to be 3, okay, plus 8 when you multiply and then add those together, okay? So you get y equals negative 12 plus 8, and you get y equals negative 4. So the y has to equal negative 4 when the x equals 3. So your coordinate that you have, your solution, the place where these two lines would intersect if you graphed them, is at 3, negative 4. Okay? You could have graphed these. One of them was already in y equals mx plus b format. The other one was not, though. You'd have to move things around. You'd have to graph it appropriately. Okay, as I've said in the past, I would prefer to do non-graphing method. This is my personal choice, okay? So again, you might say, well, why did you plug it in the second equation? Could you have plugged this x into the first equation and still got the right answer? And the answer is yes. You could have plugged that in to this first equation and solve for y. It's just easier to do the second one because it already says y equals, right? You don't have to do any other algebraic manipulation. Okay. Next one. Now, I've noticed, or I've said a couple times, you probably want to do substitution when one of the variables is already by itself. Notice that in this case, that is not the case. So in an ideal world, I would not be doing substitution here, but maybe you forget, maybe you prefer substitution, whatever. Here's what you would need to do on a problem where it doesn't already naturally line up to be substitution. In order to do substitution, you need to substitute one of the variables, meaning you need to get one of the equations to be a variable equals. Now, I don't want to have to move and divide by 5. I don't want to have to move stuff and divide by negative 3. I don't want to have to move stuff and divide by 2. But if I move this guy over, this 2c, then what can I do? Minus 2c, I get d equals, and I'm just going to leave the negative 2c in front just because, I don't know, it doesn't really matter. Remember, those aren't like terms. You get this. So now d is by itself. So this equation is kind of been manipulated. I'm not even going to look at that equation anymore. Okay, I changed that equation to be this. Now, I am at the place where I have one of the variables, d, by itself, equals something. And in this case, d equals negative 2c plus 7. Okay? So instead of d, we're going to replace D with what D equals. So here's what D equals. So instead of this D, I'm going to put it in. All right, so let me rewrite that equation. Okay, let me rewrite this equation down here. Okay, so I have 5C, that didn't change, minus 3 parentheses, meaning you're going to distribute. And then what does D equal? D equals negative 2C plus 7. Still equals 23. Again, the only thing I changed was the D became negative 2C plus 7, because that's what D equals. From this point forward, it's just basic manipulation of algebra. Again, be careful, you got to distribute. So that's 5C plus 6C, be careful, minus 21 equals 23. Like terms, this is 11C's minus 21. This is 11C equals 44. You get C equals 4. Okay, C equals 4. Cool. And then as I've shown you previously, my trick personally is just to take that, and since I made the box, it reminds me, just plug it in the box. Okay, so what does D equal? Well, D equals whatever negative 2 times my C is, which really means D equals, that's negative 8 plus 7, which is negative 1. So I get a C and a D of 4 and negative 1. Now, usually we write this as coordinates, like 4 comma negative 1. It's not X and Y, so it doesn't really do that. But if you call it, maybe put a C on top and a D on top, fine. I could live with that. I could also live with you just kind of doing this like you had there. There clearly needs to be something showing me what C equals and what D equals. Okay? Substitution. All right. Now, again, personally in that problem, I would not have done substitution. I would have done elimination, which maybe is a method you haven't seen yet, but that is what I would have done there. And when you learn about elimination, you'll see why. That would have been likely elimination problem. Wasn't horrible. Okay. It helped that the single D had a coefficient of 1. If this D right here did not have a coefficient of 1, then it would have been some sort of division. You'd probably get fractions, would not have been nice. Okay, that's why you're looking for a coefficient of 1. All right, last one here. So this one, notice I already have a y by itself. So this thing is going to substitute into there. So I get 2x plus, and then in parentheses, and not really needing the parentheses here, but I'm just going to do it for visual effect again. Again, the y has been transformed to this. Since there's no coefficient or anything in front, I really don't need those parentheses, so I'll just get rid of them. And then when you combine like terms, notice what happens here. 2x and negative 2x actually goes away. Those are gone. And you just get 3 equals 5. And so here's the next issue. There are times when doing algebraic manipulation here of two equations that your variables go away. They cancel. And there's two scenarios, okay? So when the variables all fall out, so when the variables fall out, okay, or go away, one scenario is you get a number that does not equal another number, right? So 3 does not equal 5. In that case, when you get a number does not equal the other number, that means there are no solutions. No solutions, okay? That is like a parallel situation. Essentially, these two equations are parallel, but they have different y-intercepts. So number equals another number, but those aren't the same. They're not equal to each other, actually. That means you have no solutions, okay? A second scenario might be that the variables cancel out, but then maybe you get like 0 equals 0, or 4 equals 4, or something like that. And when you get in the second scenario, a number does in fact equal another number, so they're the same number, this is when it's infinite solution. So that's basically saying it's the same exact equation. So when you looked at this graphically, no solutions was parallel, no intersection. Infinite solutions was basically they're the exact same equation. Okay, so those are really the options. You could still have, as anytime you do systems of two equations, you either have 0 answers, no solutions, 1 answer, like we've been doing in a lot of these, or infinite solutions when they're the same line.